Welcome to the Virginia Education Center for Asphalt Technology. My name's Todd Mansell, and today's talk will be on joint construction and compaction. So, transverse and longitudinal joints. So, transverse joint compaction, when we talk about that, we're talking about where we finished paving the previous day or previous shift and then set down the paver to start and continue paving again. So that's our transverse joint. Sometimes you'll hear people call them a butt joint or a night joint, but transverse joint compaction is our first topic here. So the straight edge tells the story, right? So if we're too high on that transverse joint, a little more rolling or compaction may help. We don't want to beat the aggregate until we turn it white or break rock, but a little bit of extra vibration or passes with the roller may help on the height or joint match on the transverse joint. If it's too low, we may need handwork to fill it in a little bit and then compact it. So this slide is showing a poor transverse joint starting point. So what happened here? If we look at that transverse joint, we can see it's a mill and fill job. So they've come in to mill it or grind it out and pave a new mat. Where that grinder sat down and dropped the drum or the rotor to start grinding the surface, we've got what they call a plunge cut. So they drop that rotor down initially. The teeth are spinning on that grinder, cuts into the mat, and then as that grinder takes off, that drum establishes the correct thickness or correct depth of cut. So we've got a deep area there, if you look closely, where that drum's first dropped in. And then it comes up to where it should be for uniform thickness from that point on. So we've got a rounded edge, not the easiest thing to get mix in and compact as far as meeting up with the existing pavement, but we've also got a lot thicker area there where that initial plunge is, if you will. So where it's thicker, it will compact more. So generally, a good rule of thumb is about 1/4 inch per inch of compaction for asphalt mix. So if we're a 2.5 inch loose mat, after we compact it or roll it down, we'll end up with about 2 inches final thickness. So in this case, looking at this picture, if we take off with the paver, we're going to have a lot more compaction in that plunge cut area. We'll end up with a bump there, or a dip, I should say. Good transverse joint starting point, saw cut in this case. So you can see on the right-hand side, they finished off the day before. They're going to start paving again today. This guy's out here with a masonry saw, giving a good square cut to get a nice, so we'll be able to get a mix right up to the joint. We're not going to have a tapered area where we'll end up crushing rock. And then we tack coat it and we'll set the paver down and take off from there. Another way that crews will take off with a nice square joint is put a 2x4 or something similar down the previous day and then pave out their taper. When they come back to start paving, they'll just pick up that 2x4 or whatever straight edge they put in there, clean away or waste the mix on the taper part, and now they'll have a nice square edge to start with and take off for that day after they tack coat it. So a good transverse joint starting point, measure the height of the joint. So this guy in the picture here is measuring how thick they want to be after compaction, so they have a nice smooth transition from the old pavement or yesterday's paving into the new. Why is he doing this? So that he can calculate or figure out the thickness of starter boards that he needs to set the paver screed on before they take off. So again, a general rule for compaction is about 1/4 inch of compaction for every 1 inch of loose mix that's placed on the roadway. So he's measuring it. He's going to add his compaction factor and get some starting boards to set the screed on. This picture showing the paver setup The crew are putting boards underneath that they'll end up setting the screed down on. So these boards are 3 to 4 feet long so that they go underneath the main screed and the extenders. We want to make sure we do that correctly or have starter boards long enough, but we also want to have the right thickness again to allow for the rate of compaction after we take off. Just quick review here. We all want to have a straight line of pull. So again, we're going to set the screed down on those starter boards. Before we set the screed down, we're also going to make sure our toe points are properly set. This was covered in basic paving operations best practices setup so that we get a straight line of pull when we take off. We also want to make sure we have the correct head of material, which is half auger height. So in this picture on the left, that's a view from above where the paver operator can look down in the auger chamber and see that he has half auger height head of material after we take off. So starter boards, the right thickness, the right head of material to take off at that transverse joint. So a good transverse joint will have minimal handwork. So once the paver sets down on the boards of the proper thickness and takes off, there should be minimum amount of handwork and raking to do if proper thickness of boards were used. If it is a little bit of a mismatch, you might have to rake off a few high spots or even fill in if it's a little bit low. So minimizing handwork is the goal on the transverse joint. Some rolling patterns for compaction of the transverse joint. The breakdown roller is going to come onto the mat first. Once that paver takes off, the paver should not have to stop and wait for the joint to be prepared and compacted. So again, if the crew is trained and communicating properly, that paver sets down on the boards, takes off, and just keeps going at the target paving speed. So you're not going to go 20 feet, stop the paver, and then mess around with that joint. Just keep paving. Continuous paving will give our best mat. So that breakdown roller will come on to the transverse joint. In this picture here, you can see that roller is coming from the existing mat or the cold mat on the right-hand side of the screen at an angle over top of that joint. So the roller at this point will be static, so there's no vibration turned on the roller. The first pass, shown in red, will come on at a bit of an angle and then back up on the same line. Second pass, the roller will move over a little bit. Again, still static rolling. Come back onto the hot mat again. Just being careful to go slowly and not push out that edge of that mat. Roller will back up again, and the third time it'll come back and angle on to the mat going in the other direction. So again, the key here is no vibration. Just go slowly with the roller. If you go too fast, you'll have a tendency to push that mat laterally or push it sideways and push it away from the joint. So this picture, again, showing how to compact that transverse joint initially. This is when you only have one lane width available. So in this picture, there's no room, traffic on both sides, for example, so the roller has to come at that transverse joint head on. Ideally, if space allows on the job site, the best way to compact or roll that transverse joint is to cross roll it, come at it sideways or from the side. So some jobs we can do this, other jobs, again, because of traffic, we're not able to cross roll it or come at it from the side. But if we can do it, this is the best way to compact that transverse joint. So this picture here showing how we cross roll. The first pass, again, on the top of your screen there, that roller's coming at it from the side, maybe 6 or 12 inches of that roller drum on the hot mat. The rest of the drum is on the cold mat, and just coming at it slowly in static mode. The roller will go back, come back the second time, moving over another foot approximately. So now a couple feet of that roller drum are on the hot mat now, still static mode, and the roller just continues cross rolling until you get about 3 or 4 passes completed like that. So it's just moving over gradually. The key here again is static mode and going slowly with the roller. Don't move too fast. So that's transverse joints, those compaction. The second joint that we talk about are longitudinal joints. So this is joint matching between adjacent lanes. We've got different techniques for doing that, and we'll cover some of those techniques as far as compaction and rolling goes, but before that we'll talk about how to construct that longitudinal joint. The compaction of a longitudinal joint is only as good as how it was built. So with that, build it right. So the paver's got to leave a straight edge for us to match up against. It's got to make consistent joint overlap whenever possible, and we'll talk about that. And there is an option you'll see on some rollers, like in the picture in the bottom right there with a cutting wheel on it, and we'll show a few slides on that as well. But we've got to build that longitudinal joint properly before we can even think about getting good compaction or good density on it. So joint overlap and joint height are the main things as far as the paver goes. The end gate overlap, generally about a half an inch to an inch. It depends on the size of the mix, so a half inch or a finer mix, even less overlap. Larger stone mix, we may have a little bit more overlap. But if we have a good longitudinal joint on that first pass, that unconfined edge, when we go back to match that lane, we don't need a lot of overlap. So that's our overlap, our pre-compaction height. Again, remember about 1/4 inch of compaction for every inch of loose mix. So when we're joint matching, we've got to be very careful about how much mix we put down so that after we roll it and get density, we have a nice match between lanes, or that longitudinal joint. And the goal here, if we're set up properly, no raking. So raking does two things. It pushes mix away from the joint, and it also causes segregation and even just surface texture issues on that longitudinal joint. And if we're using automatic grade control, we can use a single sensor on the grade control, and we can use an averaging ski and get a nice longitudinal joint if our initial lane is very smooth. So there's a couple ways of matching that joint using automatics as well. This slide just shows end gate overlap. In the top picture or image, you'll see a good longitudinal joint. So on the left side, you see the cold mat. On the right side, the darker asphalt in that image is the hot mat. So we have a little bit of overlap there. And the reason we can get away with a minimal overlap is because that first lane was paved with the end gates down and a nice square edge. On the lower image, you see the left side, that first mat or that first lane was paved with the end gates up in the air. And when that happens, the mix kind of fluffs out underneath at the edges of the screed there, tapers off. Then when we come back to match now, we have two things going on. We have to have a lot more overlap, but what's going to happen in that narrow area there where there is not very much thickness? So there's two things that go on. The first lane, when it was paved, that tapered part never got compacted because we can't get a roller on that taper. And then after we match the lane like this, we're going to end up crushing a lot of rock in that real thin area. So you're going to see some busted aggregate, and it's going to be low density in that area where that taper is. So real important to have end gates down when we pave that first lane, and then also the overlap of the end gate onto the existing mat when we come back to joint match. A couple pictures here just showing some idea, give you an idea on overlap. On the left-hand picture, it's a good overlap, even though you can see that first lane they did pave with the end gates up in the air a bit because it's not a nice perfect 90-degree, but they do have good overlap there on the left side. On the right-hand side, way too much overlap. What's going to happen there? That's, for one thing, it's going to be a heck of a lot of work for that person on the rake behind the screed to push all that mix onto the new mat. And it's going to look like a mess. It's going to be segregated and everything else. So no need for the big overlap that you see on the right-hand side there. This is what you might see a year or 2 or 3 later if you get excessive overlap on that joint and then have to rake some of that mix off. Might not look too bad initially, but a few years later, you see a crack showing up, and it's where that material got raked off of that longitudinal joint at the time of paving and compaction. So the real solution here is to control end gate overlap of the new mix onto the existing lane. So again, raking is not the answer on the longitudinal joint construction. It's going to create segregation. It pushes mix away from the joint. This picture is rakers gone wild, so you can see mix all over the place on this mat. Really not necessary. Light bumping is acceptable with the larger stone mixes. So we get 3/4, definitely. If we get into 1-inch large stone mixes, it's quite possible we may have to use the lute or the rake and just lightly bump that joint, but don't broadcast the mix across the mat. This picture is just an example again of over raking, but if you look in the lower left, you can see how much raking they did along that joint. There's really no need for that. There's just too much material there. They really needed to adjust the height or thickness at the screed so that they got the proper joint match, and after roll down it would match up. They don't need to rake all that material off of the joint. In the top left you can kind of see what happens again. On the left side you put the rake down on the cold mat and you push material onto the hot mat. You get segregation, but you also push material away from the joint and you end up with a lower joint density there. When you look at the right-hand picture, I've seen a lot of roadways like this. Which side was paved first? I think it's pretty easy to tell, right? The left side was paved first. It's nice and uniform right up to the edge. And then they paved that second lane and they broadcasted mix with the rake back onto the second lane as they paved it. And you can see the difference in surface texture, and that's just from raking. Even that, if it's severe enough, can end up leading to water sits in there, it freezes, thaws, ends up leading to raveling. So end gates down, as you can see in this picture on the first pass, nice square edge, good vertical edge, and have enough auger extension and tunnels or mainframe extensions to get the mix all the way to the end gate. This video is a 1-inch mix on an airport job. It's just showing, even though it does look a little coarse, it's because it is a 1-inch mix. But no raking, end gates down. After a few roller passes, they've got a nice joint match, good densities, because they were paying attention to the thickness being placed by the screed. The next slide here will just show a little more on the compaction side, but again, large stone mix, no raking, just because the screed people paid attention to what they were doing in terms of thickness. Again, good joint match there. After the fourth pass going back there, you can see it's almost a perfect match. Good joint densities. Another little clip here showing a 1/2-inch mix. Again, end gate down to get a joint match, no raking. This slide showing a notch wedge joint, doing too much raking in the right-hand side there. But what I really wanted to show here was more just, we talked about a square edge or that vertical joint on the first pass. This is just a different type of joint, called a notch wedge joint. They're used in some areas, primarily used so that they don't have to button up a lane or match lanes between shifts, so that it allows traffic to be able to transition between lanes during construction, again, without having to button up or close up that other lane during the same paving shift. So those are used in some areas, but just a different, it's an insert that goes in the screed to create that little notch, which is basically a short vertical portion, typically about 1 inch, and then tapered out from there at anywhere from 8 to 12 inches of a taper. So on the first lane, building that longitudinal joint and now compacting it. So the first lane we've paved with the end gate down to get a nice square edge. When it comes to rolling, on that unconfined edge on the first lane, get about a 6-inch overhang of that steel drum roller. So when we overhang it like that, that steel drum is rigid, so we get the most vertical or downward force on that longitudinal joint as we can. So we're getting the best compaction we can get without that joint actually being confined or held in place by an adjacent lane. This slide just showing them rolling from the hot side. And the reason we like to do that is when we're matching lanes, if we roll from the hot side, we can vibrate as opposed to rolling or pinching from the cold side where we can't vibrate on the cold mat. So we're taking advantage of temperature by rolling from the hot side. We're able to vibrate from the hot side. And if that mix is moving at all laterally, it's confined by that cold mat. So we're pushing it, kind of pushing it into the joint, if you will, locking it in. For the highest joint densities, as you can see in this video, the operator's leaving about 1 foot or a little more of a strip along that longitudinal joint where they're matching lanes. So at the end of his pass here, he'll roll off. You'll see on the next slide, he rolls off onto the cold lane because he can here. They've got traffic blocked. And then he'll come back and compact that 1 foot section. And because it's locked in there and can't move sideways, they get the highest joint densities rolling or compacting the joint this way. Here comes the operator back to compact that 1 foot strip in the center. And they've also got good height match. So you'll notice they're not raking either. So once this is all done, good height match, no raking, the joint's locked in, the densities are pretty much exactly the same as they've got right in the main line of the mat. Another good practice, if you have a rubber-tired roller or pneumatic roller, after the steel drum rollers compact that longitudinal joint, run that rubber tire, straddle one of the tires right on that joint. Because of the kneading action of the rubber tire, it tends to really force mix into that joint, and it can tighten up that surface as well. So pneumatics do a really nice job on longitudinal joints if you follow up the pneumatic after the steel drum on that joint. On an unconfined mat, you want to keep the pneumatic off of the joint. So as you can see in this video clip, that operator's staying close to 1 foot off the edge of that mat. And the reason he's doing that with the rubber tire is just so he doesn't push the mat out sideways or laterally. Once he joint matches, then as we showed in the previous slide, he can straddle that joint with the rubber tire and get really good joint densities. Edge cutters, just showing this just as a informational thing, but it is an option you'll see on rollers. Some jobs require that longitudinal joint to be saw cut or trimmed, mainly airport jobs. And one way of doing it is using one of these, I call them pizza cutters on the roller, but it's just a cutting wheel on a hydraulic arm that raises and lowers. And while there's still a little bit of heat in the mat, you can trim off an inch or two of that longitudinal joint before you come back and lane match or match lanes. And the idea there is just to get a good vertical edge again, because our density on the outside edge of that first lane is always going to be a little bit lower because it's not confined. This is just one way of trimming off that low density strip on the outside edge and that before we lane match. And again, mainly trimming that longitudinal joint is required on a lot of airport jobs, but not on normal highway jobs from what I've seen. Another key thing with the steel drum, so we showed earlier on the unconfined mat hanging over the edge about 6 inches on the first pass. What we don't want to do is run just inside that edge, as you can see in this picture. Because what happens, two things. One, it'll tend to push the mat out sideways again. It's not confined or locked in any way. And it may look nice after you finish paving it, but it might be a year or two later. There's high shear stress along the edge of the drum between the drum edge and the pavement. And a year or two later, it may end up seeing a crack along the edge of pavement a few inches in from that edge. And this could very well be the reason. So either hang off that edge 6 inches, like we showed earlier, or stay in a lot further, a foot on the inside. But try not to run right on the edge or right close to the edge like this. So properly built and compacted joint. We got that good square edge on the first pass. We come back, end gates down again, the right overlap, the right height for compaction or roll down. No raking, should pinch down, get a beautiful joint match, and have a good high density along that joint. Because this is where our pavements generally fail first, is on that longitudinal joint. So building it right, compacting it right, we're going to end up with a quality joint and a quality pavement that's going to last for a long time. One of the last things here on roads, particularly county roads where we may have crown at the center line, 2% going each way for drainage. Just be real careful as a roller operator not to roll out that crown. So in this picture, if you look closely, you can see daylight under the rear drum on the far left, or a bit of daylight on the right side of the front drum. That operator is rolling right on the crown of that road. We want that crown in this case, so the water drains from center line to the left and right shoulders. So just be careful as an operator. Don't roll the crown out. Keep the roller all to one side while you're compacting any road where you've got crown in the center. So to summarize, the paving crew builds the joint correctly. Again, that's end gates down, everything to do with the screed and paver setup. And then they're going to verify their overlap. So whether it's 1 inch or ½ inch overlap of from the new mat onto the cold mat with the paver, and their compaction height so that we don't have to rake it. And then pick a rolling pattern that meets our project requirements. So again, transverse joints, best to cross roll them if we can. If we don't have room, we got to roll them head on, but do it slowly, do it in static mode. And then longitudinal joints, overhang 6 inches on the unconfined mat. When we're joint matching, roll from the hot side, overlapping onto the cold mat about 6 inches and vibrate. Or for the absolute highest joint density, make that first pass on the second lane about a foot off of the edge, leave that little strip on the joint, come back and compact that, and you'll get some really, really good high joint densities that way because everything's locked in and confined. So with that, thank you for your attention today.